Good afternoon. Dear authors and invited guests, I welcome you all to the technical session 10E. Myself, Siddesh Mogal, and this session will be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the technical session 9th International Conference on Information and Communication Technology on Intelligence System, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom yesterday and today, that is 5th and 6th April 2025. I hope you will enjoy the knowledgeable and interactive session through the day. This session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of the session. Our first chair for the session is Dr. Priyanka More. Dr. Priyanka More is an assistant professor in a Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune. Her research interests include image processing, machine learning, natural language processing, and the Internet of Things. Ma'am, I welcome you to the meeting. Would you like to give any opening remarks to the participants?
Yes. Thank you, sir. Thank you for the invitation. Am I audible?
Yes, ma'am, you're audible.
Okay. Yeah. Thank you. And welcome everyone to ICTIS and for your research journey. And I welcome you and thank you all for being part of this conference.
Thank you, ma'am. Our second chair for the session is Dr. E. Sujata. Dr. E. Sujata is a professor in the Department of Computer Science and Engineering in Savita Engineering College, Autonomous, Chennai. With 25 years of academic and research experience, she has published extensively in Corpus and SCI journals and is a lifetime member of ISTE. Her research interest includes biometrics, soft computing technologies, network security, pattern analysis, and image processing, contributing to advancement and intelligent and secure computing system. Ma'am, would you like to give any opening remarks to the participants?
Good afternoon, sir. Good afternoon, all of you participants. You have to share your knowledge, whatever you have experienced for your research. Looking forward for your research findings. Thank you.
Thank you, ma'am. Now, I would like to start with the presentations. First presentation is by Hema P. Menon. She is presenting the paper title 3D Brain MRI Reconstruction Exploring Axial, Coronal and Sagittal Views with Interactive Slicing. Hema ma'am, are you there?
Good afternoon, everybody.
Yeah,
Am I audible?
Yes, ma'am, you're audible.
Okay, yeah, thank you so much. I am Hema. So shall I share my screen?
Yes, ma'am, now you can share your screen.
Yeah. Is it visible?
Yes, ma'am, it's visible. Just put it in slideshow mode.
Yeah. Okay. So thank you once again for giving this opportunity. And I would like to say that I'm Hema and I'm presenting on behalf of all co-authors. So this is actually the work done by my students. And since they are having their exams, I have been asked to do this presentation. So on behalf of them, I'd like to start the presentation on our topic on 3D brain MRI reconstruction, exploring axial, coronal, and sagittal views with interactive slicing. So I hope the screen is now properly visible, right? So can I continue?
Yes, ma'am, you can continue.
Yeah, thank you. So to start with what I'll be presenting today, so this work actually presents a development of a system that enables 3D reconstruction of brain images from axial, coronal, or sagittal slices of the MRI scans, that is magnetic resonance imaging scans. And the concentration is on the mutual information and cross correlation based registration. And additionally, the model or the system also includes a feature for interactive slicing, which actually serves as a teaching or learning tool for medical students or interns. So this is the entire CRISP was what I'm going to present. And as an introduction, I've just included a brief on what is sagittal, axial, and coronal. So these are the three views in which we get output of an MRI scan. And in our work, we are asked to process each of these views separately and create a 3D model from each view separately. And this entire project was actually developed under the expert guidance of Dr. Anand Kumar from Amrita Institute of Medical Science, Kochi, and Dr. Davidson Devase, who is now with Astromedicity, Kochi. So this product that we have developed is a part of a big project, which was for developing an atlas for the brain. And that atlas would be used by students for learning different parts of the brain image, for which the preliminary step was a 3D model development. And all this that I'm presenting today is based on the preliminary work that is being done. And the system requirements were given by the doctors. And the system requirements they had it was totally customized. Because why I'm stressing on the system requirements is because nowadays you actually have there are many toolkits available, okay, like whether it is a slicer or it's for 3D reconstruction or an atlas. Existing, there are many tools available. There are many systems available for that. But what the doctors felt was it is very difficult for them to interact with it, because sometimes there are some cases which they want, which is not there in that particular system or model. So that is where this work was started actually. So it's a customized model, and they wanted something which is very simple and user-friendly, simple based on their terms. And they wanted a model which can be developed from 20 slices from an MRI. So the number of images that we are using to do the 3D reconstruction is just 20 slices, and which 20 slice will be decided at that time. And it is just a one-time model development because it's for a learning and teaching kit. And for the development, what they wanted is a less time-consuming model, and it is to develop a customized atlas. So based on this system requirements is what I'm going to present this paper today. Why I'm stressing on this is because in this era where we are actually concentrating more on artificial intelligence or machine learning based system, which actually does these things much pretty faster. What I am presenting today is the conventional or the age-old methods. The data sample, I'm just giving the data sample that we have used. So 20 slices from axial, coronal, and sagittal. These were acquired using the MRI scan process of one person, anonymous, of course, who has been authenticated as not having any disorders, etc., because it's for a proper brain development. And each size, image size was around 512 cross 512. Initial format DICOM converted to JPEG for processing, and number of slices considered 20. The overall process overview, we have three main processes. One is registration, surface rendering, and volume rendering. And once these three are done, then a slicer module is developed where the students can interactively slice and learn the parts of the brain. So this entire project, because it was a prototype that was developed initially, was built in MATLAB. So what I've just given is the MATLAB functions in case needed. Though nowadays we have converted this or ported the entire thing into Python. So for MRI data acquisition, and once the MRI data has been acquired, once 20 slices, it could be a 100 slice CT scan or a 50 slice CT scan, of which any 20 slices may be selected, or it could be a scan wherein only 20 slices are acquired. So that depends on the doctor's requirement. So from that, these 20 slices, whichever the doctor is selecting or which are acquired, is then registered. And here for registration, we use a simple point-based registration method. And the registered data are then subjected to volume rendering and surface reconstruction. So just going into depth of the system highlights, 3D reconstruction or the creation is done from a single patient's data at real time. So that is one. The system is not based on any learning or training model, but instead utilizes a conventional approach, which is exploiting the characteristics of the image and its type. It works with minimal number of images. compatible for variability in the images obtained. And once it is developed, the system need not be changed frequently. That is, there is no need wherein I have to develop a system which has to learn from something. Because once a doctor certifies that, okay, this brain or this sample or this subject is good enough for studies, that remains like that for quite a period of time, unless and until their training objective or the learning objective changes. So it's like a one-time model that was needed to be developed. And that was one of the reasons why a learning or training based model was not needed. Okay, it's not like it's not suited, but it was not needed. And second thing, why a learning or a training based model was not used is because of the number of data set. We just have 20 data with us from which it has to be created. And it is customized and interactive. So these are some of the highlights. So yeah, starting with brain MRI image registration. The need for this is aligning the sagittal, axial, or coronal MRI slices. The 20 slices that have been considered have to be geometrically aligned one with respect to the other. So that is the need for or the purpose of using an image registration in this case. And for registration, what we used was a simple point-based registration, which could otherwise be called as a feature-based or what is that? Yeah, a landmark based. So these features and landmarks, since we had the doctors with us, they used to tell us, okay, in this slice, so the 20 slices that the doctor selects, they used to tell these are the points that are there in slice 1, in slice 2, slice 3, and so on. So it is, since this data is available with us, it is easy for us to do a point-based registration. And for transformation, an affine transformation was selected because there are times when, like, if I talk about a brain structure, it is rigid. Though it is like rigid, there might be some structures internally which might be non-rigid. So that being the case, an affine transformation was selected. Otherwise, if you look at a brain structure, and if I'm concentrating only on the outer surface, etc., then a rigid transformation as well would be sufficing. So the need for this is, if the registration process is not perfect, or if we do not give much concentration on the registration process, what happens is the 3D volume that has been reconstructed will definitely have some artifacts in it, like the alignment issues may be there, and the smoothness of the outer surface, that creates a problem. So that is the importance of image registration in a 3D reconstruction process, and which is what I'm presenting now. And here, the entire registration process, we select one slide as the target slide and the other as the source slide. So if now I'm having either 20 axial slices, or I'll be having 20 coronal slices, or 20 sagittal slices. Okay, so whatever I'm registering is of the same type, and it is acquired using the same modality. And they all are T1 weighted. So it is not a multi-model registration that I'm looking at now. Now I'm looking at only a monomodal registration, and not a registration between axial and coronal, or between axial, coronal, and sagittal, but a registration between the different slices of an axial view. So that is what is required. So in that case, among these 20 slices, one of the slice has to be fixed as the target slice. Now, which slice to be fixed, that is given to the doctor's choice. Either it could be the first slide, it could be the last slide, or it could be a slide in the middle. Now, generally, a center slide was fixed as a target. The reason is the first slide, which actually, if you could see from the data set, has got very minimal data. So choosing the first slide. Hello?
Sorry to interrupt you, ma'am.
Yeah.
Your minutes are over.
Am I audible now?
Yes, ma'am, you are audible.
You can see the slide?
Yes, ma'am.
Okay. So can I proceed?
Yeah, ma'am, you can proceed.
Okay, so the first slide, as I said, in this data sample, the slide that is numbered as 01 has got very minimal information in it. So generally, keeping such a slide as a target, especially in case of a point-based registration, may be difficult, or it may not give you the correct result. So what is done is an intermediate slide, maybe slide number 15, 16, or sometimes slide number 20, which has got more details, could be kept as the target slide. So in this case, the center slide was kept as the target slide so that there is a balance between both the sides. Okay. So that was a point. That is how the target and the source slides were fixed. And a point-based, the points were selected from each slides. And slice 1 was registered onto the target slide. And the registered, all slides were registered based on the target slides geometric transformation or the orientation. So all slides are now aligned in the same geometric coordinate system. So this was the registration process. And in this, when we are computing the similarity, we had to compare between two similarity measures. One is mutual information and the other one is cross correlation. So now, why these two were selected is because we are looking at the same modality. I'm not going for different modalities. I'm only looking at MRI. And for time being, what I have used is only MRI from T1. Mutual information because when I look into different slices, they share the same information. And cross correlation, why? Because when I look at the first slice and when I look at the 15th slice, the mutual information is less, but there is a correlation between them. Okay, so by sliding one image or the other, it is easy for me to calculate the correlation rather than the mutual information. So keeping these two concepts in mind, we looked into how mutual information works and how a cross correlation based similarity measure works. And these two were computed. And theoretically and practically, it was confirmed that mutual information is robust for multimodal image registration in case I had to register T1 and T2 weighted MRI scans. And cross correlation was best suited when it is a monomodal or a single modality image registration. That is MRI scans from T1 weighted and I'm having only axial, nothing else, or only coronal. So in that cases, cross correlation based similarity measure found to give a better results. So the steps we have just listed, but the only difference between the two was there was a slight overhead for mutual information based, wherein we had to calculate the joint histogram and the entropy because that is used to find out the mutual information. And in cross correlation, we are just finding out the cross correlation between the two images. And whenever the similarity measure, we put a small threshold, and based on that threshold, whichever achieved a higher similarity measure was fixed as a method which we are going to proceed to with for our isosurface creation. So the similarity measure for CC base was found to be 0.889, which actually and MI was 0.790. Now, this 0.889 or 0.790 is again dependent on the slices that I have chosen. So what I have given here is a sample of one set of slices. So the example that I've given here, 20 slices for that. Now, when the slices were changed and the, if I select slices which are pretty near to each other, the similarity measure changes. So I would get a better similarity. So it's almost towards 1. Now, this is like wherein it is not that similar. So then you get it little less. So that is the... Hello?
Sorry, but
Am I not audible?
You're audible, ma'am, but your time is up.
Oh, okay. Then I'll quickly finish. So that was a similarity. So reconstruction. So this was the difference between reconstruction in MI and CC. So CC gave a better thing. And texture mapped, what we did in isosurface extraction was creating an interactive model for value selection because whether they have to select a value of 60 or between 60 and 120 for the different parts of the brain, doctors wanted a selection for that. So an interactive model was created. So this is an add-on that is I can highlight from our method. And a matching cube based method was used. And for volume rendering, a texture mapping based volume rendering was used. The advantage is it gives the user flexibility to rotate, zoom, and explore the entire volume. And sync interpolation, linear and cubic interpolation measures were tried, and sync was found to give a better result. So these are the examples of the 3D volume that was rendered and created, and a sample of the GUI that we had created for the use by the interns. So conclusion, I would like to conclude saying that we had created a 3D image creation from a single patient data with 20 slices of either axial, coronal, or sagittal slices, and with a completely interactive device which could be used by the doctors based on their concerns, where they can select the slices, they can select the ISO values, and they can see how the rendering has to be done. So it is totally a customized product that was developed for an Atlas development. And these are some of the references. Thank you, and open to questions. Sorry for taking long time.
Ma'am,
Yeah, yes, ma'am.
how many images you have trained and you have given as an input, and what is the success rate out of it?
Yeah, ma'am, that's what I said. Like, we have not used a training model. What we have used is a simple conventional registration model. So,
That's
which
what, how
means
many
I don't
images
need,
you have given as
we
an
just
input?
need 20. We just need 20 slices from any of the views, either axial or coronal or sagittal. What we need is a minimum only 20 slices, not more or not less can work, because that was a requirement.
What is your
So,
success rate
yeah, so
for all?
pardon. Success rate is that what similarity measure is the one what we are looking into, right? Because it's not a learning model. So I'm not looking at the accuracy. It's a 3D model that is developed. So there, the similarity that I'm getting, the highest similarity was around, it is between 0.889 to 0.99 something, depending on the data set that is used. The similarity that I've presented today is based on the data set that I have represented in this paper. So here I'm concentrating on the similarity measure.
As the outcome of your
The outcome of the project is
commercially, did you made available this for doctors or patient caretaker? Will you make
this is
it
made available to the two.
your project?
It is made. This product is made available to the doctors as an interactive toolkit, and the work is still continuing because it's a project which we are doing as a part of an MOU with Aster and
as a
AIDS.
doctor, if I want to make use of your product, where it is available, may I know the URL?
Yeah.
Is it available for me to use?
It is not available for anyone because it is only available with the. No, it is not available, ma'am. It is only available with the doctor and with the institute. So it's a part of a project that was done as an MOI. Dr. Anand Kumar from Amrita Institute of Medical Sciences, Kochi.
Okay, thank you.
So thing is like, it is not complete. As you said, like we have done all conventional methods, and for the ISO value setting, we have given the manual values, like between 60 to 120, the doctor has given the values. So now we have a set of values which probably could say that, okay, if it's a gray matter, this is a set of probable values which the doctor has given. So now that process that is there, now we will be using any learning model like CNN to model it, to automate that entire process, because once the data set is there, that can be done. ISO value selection can be made as a learning and learning model. The remaining parts, still what we're using is a conventional models that are available because of the two things. One is time consumption, and second one is lack of data. It's not lack of data. It is like they want something which can be developed from the minimal data. So that was the constraint given to us. Have I cleared your question, ma'am?
Hello.
Yes, ma'am.
Yeah, Hema ma'am. So just
Yes, ma'am.
20 scans you have taken, right? And you are saying that from three perspective you are collecting it. So for axial you are taking 20, for coronal 20, like that way?
Yeah, 20 for axial, 20 for coronal or sagittal. So as I showed in my slides,
60.
the
In total 60, right?
no, at that time only 20, because in the model that is developed, we have three options. To create a model, I can select either 20 slices of axial or 20 slices of coronal or 20 slices of sagittal. So when I select from axial and I have developed the model, I can recreate the because I have given an interactive slicing, using that axial sliced 3D model, we can have a planar cut. So from that, I can see the coronal and the sagittal views as well. So that is why we have
Okay,
given an
so
interactive
depth
slicing
factor is
option.
considered. Depth factor is considered where?
Pardon me?
Because when you're constructing a 3D model, okay, so the depth of each part should be considered, right? So how depth analysis is done?
Actually, here we have used two things. One is we have used in the ISO surface, we have used a marching cubes algorithm. And for volume rendering, we have used a 3D texture map and a ray casting method. So
Okay.
that is how we have done. And here I have not put all details because my concentration in this was on mutual information and cross correlation, like why
Okay,
that
Do you
is
have
being used.
pseudocode for this algorithm?
I am sorry, I don't have it now because I didn't know that you have to give a pseudocode. So like I just kept the functions that have been used. Because it was developed in MATLAB. Yeah, so like I've just kept the functions which we used mainly. I don't have a pseudocode. I'm sorry for that.
Okay, fine.
But yeah, this is the slicer we had developed. So this basically is a GUI wherein the 3D model is created using an axial slice, and an option is given where I can cut it along any plane so that I can see the interior. So if I want, I can cut it along axial, coronal and sagittal. So using just a single 3D view created from axial, the interns can see how a coronal or a sagittal view would look like. So it's basically a teaching or a learning toolkit. So this is what we have done. So at a time, the dataset size is 20 slices.
Actually, using MATLAB, you can reconstruct any image, 2D image into 3D image. What is your novelty and contribution?
Ma'am, actually, yeah, that's what I said. The novelty here is only in making the system much interactive. So wherein the entire concept for ISO surface extraction, giving the ISO value, for all that, we had to create a interactive device wherein the doctor could give the interactive values. He could select which is the best value, etc. So it's a customized product which we have developed. And second one was the use of, mainly it's the the end product that was matters, like that is the development of the entire system which a doctor could use in his way. So that, like, if you ask a technical novelty, I don't think there's anything that is technically novel because all methods, as you said, are available. So the highlight of the system would be it works with minimal data set. If whichever slice the doctor says, that slice can be used for generating the 3D. So the novelty lies in those concepts rather than in the algorithmic part. So it is in the building or it's in the entire system part.
But it's already being, I mean, when we used to get that MRI sheet, no? So on that sheet, we are getting so
Pardon
many
me?
images. When we are getting that MRI sheet result, okay, have you seen that actual sheet? Because recently I have gone through MRI scan. So already I'm having, I mean, on that sheet, almost 25-30 images they have represented. Okay, and only those images where that part is infected or impacted. So only that part they have given
No, ma'am.
almost 25-30 images. So
No,
where
no.
this will be used?
No. No, that's what I'm saying. This is not used for learning. It's basically not to learn any disorders. It is just to learn a brain parts. So this is the first part. Now, the second part of this entire work is actually an atlas creation. So wherein the model that is created does not reflect any disorder of the brain. It is of a person who's having a normal brain so that it can be used to learn the brain parts for the interns. Now, from this, if you could see each of these slides, like the part that is there is actually labeled. So that is the next part that is there, which I have not included in this. So there, when the intern just points at any of the place, he can see what it is and what is the functionality of it. If it is affected, what happens? So that is the atlas. So to create that atlas, this 3D model have to be developed. So each of the slice that is developed here is actually a labeled and tagged version. So what happens is when I slice it, for each slice, when the intern clicks or just points at a place, what is it? Is it a ventricle or is it corpus? Is it corpus callosum? What part of the brain is it? That is actually highlighted and shown. So it's a 3D model that developed from the initial slices. From that, we are creating each mod part is then labeled and it is stacked. 3D is created. And when you cut it in planes, and when the patient person wants to learn something, he can just point at the screen and he can learn, okay, this is corpus callosum, this is ventricle, or this is the gray matter. So this is for a learning kit. So there is no disorder of the brain that is considered anywhere.
Okay. So you are saying it is for learning
There's a
purpose, right? Giving
It is
training to
it's
each
only
other.
for learning purpose. It's
Okay.
only
But
for learning
already,
purpose
yeah,
and
but
for
already
teaching.
many hospitals and many medical colleges are having AR VR based learning libraries. Okay. So they are already using all these. So where is the your novelty of where is the difference between these two?
Yeah, ma'am. That's what I had told initially. It is like, I think when I started my presentation itself, I told, because like there are many such models already available. But what doctors felt is if they want to change something in that model, if they feel, okay, now at this point, I want to change this, I want to insert something else, that was difficult because it's an existing model, right? Now, if this model has been developed and it
No.
is with a
It is
doctor.
already there because even dentists also having, because I have myself witness all this. Okay, so my
Okay.
dentist is having already that library, and he used to show me, okay, this part is impacted now, here this nerve is getting impact, and like that way. So already they are having such libraries.
Yeah. Yes, ma'am. You're absolutely right. That is an interactive model that is there. But the difference is in the creation part, right? When I'm creating the model, if I want to make any changes, there, if they want to change the atlas part where the labeling has to be changed, in that place, they were finding it difficult. And labeling the atlas, etc. If the label, if as per the doctor's requirement, they wanted. So this model was developed only for that purpose.
Okay, fine.
Okay, ma'am. Thank you.
Yeah. Good luck for completing yoga. Thank you.
Thank you, ma'am. Thank you so much.
Up next, we have Samana Jafri. She is presenting AI for accurate cancer diagnosis in prostate biopsy and grading assessment using VGG16. Samana ma'am, are you there?
Yeah, I'm there. Am I audible?
Yes, ma'am, you are audible. You can
Yeah,
present
I'll
the
share
screen.
my screen.
Yeah. I kindly request to all the participants to uh, end their presentation within the time, as we have time constraint.
Okay, very good afternoon to one and all. I'm Samana Jaffrey, a research scholar at D.Y. Patil Institute of D.Y. Patil deemed to be University at RAIT, Mumbai. My topic is AI for accurate cancer diagnosis in prostate biopsy grading, assessment using VGG16. Now, this is the outline which I'll be moving through. First is the motivation of this project. Motivation of this project is prostate cancer being one of the most prevalent cancer among the men worldwide. We see that the data shows that it's affecting approximately around 1.4 million people every year, with new diagnosis of 3,75,000 with new diagnosis and 3,75,000 deaths per year. Every year, this is the number of deaths which we see among men due to prostate cancer. So accurate diagnosis and effective treatment planning would be the crucial part in it. So generally what happens is more number of prostate biopsies are done Yeah, prostate biopsies are done, which to detect this prostate cancer. Firstly, there are two ways of detecting the prostate cancer. One is using MRI, and second one is using the biopsy method. So first when the MRI is being done, to predict that MRI, it requires high level of expertise, and there is always invariability among the doctors in reading the MRI. And so that is the reason, after if it is detected in MRI, they generally go for prostate biopsies. And these biopsies, if it is not cancerous, unnecessary, there are many side effects which occurs due to biopsy. And if it is a low cancer, if it is not that very required kind of a thing, then it is the biopsy which is unnecessary done is like affects the patient. So that is the reason we have tried to do this using AI, wherein we try to detect this for better patient outcome, for the better patient outcome, so that the patient will not have to go through the biopsy if in case it is not needed. So this histopathological image which is there is the image which is used for biopsy. So this histopathological image basically gives a detailed cellular and tissue levels inside, and these tissue samples are examined by the pathologists whether the cancer is present in that tissue or no. And based on that they give a grading, which we call it as a Gleason grading. Later this Gleason grading is converted into ISUP grading, which ranges from 1 to 5. So basically what we have tried to do here is we have tried to use machine learning algorithm to automate this process, which is done by done by the pathologist. So so that there is no invariability between the pathologists which are doing the grading, and it gives better results. So so the patient should will not be going through the all the process which is done unnecessary. So this is the proposed framework of our model, wherein first we have taken the whole MRI image, whole biopsy image. This is the whole biopsy image which is there. So first to this image, some pre-processing we have done to the entire image. The pre-processing which is done to the biopsy image, wherein we first did ROI selection and tiling of the image. ROI was done so that we actually select the cancerous tissue from the normal tissue which is present. So the background and the normal tissue was masked using the magnification and the masking technique, and we could exclude and focus on the tumorous region. So first the entire biopsy image, say for around 4000 by 4000 pixel image, was cropped into a small ROI image, which you can see here. Later on this image, tiling process was done, where we divided this ROI into 16 equal tiles of 2 to 4 into 2 to 4 into 3, representing the width, height, and RGB, so that it could be fed into the VGG16 model. Now the data set which we have used here is from the Panda challenge, which was freely available, publicly available for on Kaggle, where entire 10,616 whole slided images were present, and these images were validated by urologists which were practicing, 6 different urologists which were practicing in United States or Canada, and we used those images, and we did all this pre-processing on these images, where the ROI selection and the tiling was done in the pre-processing stage, and later we splitted this data set into the training and the testing, where 80% we have considered for training and 20% for testing. And in that training, again, we splitted it into, yeah.
Your 9 minutes are up, so kindly wrap up your
9
session.
minutes are up. Okay. Okay, so training data set was 80% and 20% was for testing. And then we provided this to the architecture, the VGG16 architecture. This model was given to the VGG16 architecture, which went through the different layers, as you can see here. First, this input was given to the input layer, where 224 into 224 into 3 was the input was fed into this VGG, and then it was given through the convolution layers, subsequent convolution layers. The first convolution layer applied 64 filters of size 3 by 3 with ReLU activation. This was for features such as edges and textures within each of the tiles, and then other extractions such as complex features extractions, like tissue patterns and structural details, were further evaluated on further convolution layers. Then batch normalization was used for speeding up the entire training process and improving the convergence. Then max pooling technique was used, wherein what we did was we reduced the feature map of 224 into 224 into 64 to 112 into 112 into 64 dimensions. Then we gave it to the flattening layer, wherein it was converted into 1D vector of size 25088, and then again it was given to the fully connected layer, first to the ReLU activation function, and then to the softmax activation function. Fully connected layer, first we did the ReLU, so that in case the feature for the feature which learns the patterns of feature extracted features, and then it was given to the softmax activation function to predict one of the ISUB grades. Then we trained this model. On all this using ADAM optimizer at a learning rate of 0.001, and loss function which was considered, so that if it is ISUP grade 3, then that same should be realized. And it was run for 15 epochs. It was run for 15 epochs. You can see the output here. This we have seen all these evaluations where we have seen the precision, specificity, and then the recall and accuracy. We have plotted the matrix, confusion matrix for this VGG16, different performance matrices, and the test accuracy which we have seen was around 89.8%, was the test accuracy which was seen using this. And this was the training and training accuracy and the training loss. The system was run for 15 epochs with a batch size of 32. That means at a time 32 tiles were used for processing. So this was my paper, which was done using VGG16 to automate this entire process of converting it into classifying into USB grades of 0 to 5.
Ma'am,
Yes.
who's going to get benefit out of your research findings?
See, it
Who's
is the
your
patient.
applicant actually?
Sorry.
Who's going to use your application, ma'am?
See, it is the application is basically, see, this paper is particularly I'm trying to detect what will be my results. That is, what is my test accuracy if I'm working with only biopsy images. If I'm working with only biopsy images, what is my results? Then I have also presented one more paper with MRI images. What was my test accuracy for MRI images, and then wherein
No, no,
I'm
no. My
registering.
question is
Yeah.
for whom you have done this project?
See, this is basically aimed for the doctors, to have better prediction. Because what happens is when you go to doctor one and you go to 5 different doctors, everybody will give you different predictions. Some would say that it is Gleason score 5, some would say it is 3, some would say it is 4. So when you make an automated model to them, so it gives them a more, they'll be able to predict it more precisely, because the model is giving them a very close view.
When you conduct literature survey, did you find any accuracy of the similar paper with some different accuracies?
Because the actually the different literature survey which I have done, this method of converting it into slices and using it, they did not use that. So I am basically considering only the only the cancerous portion. If you can see here, see only the cancerous portion I am converting it into the Gleason score. Okay, they have selected the entire biopsy image, wherein the normal and the
No,
background is
ma'am.
also selected. Yeah.
During literature survey,
Yeah.
did you find any other same kind of a
Yeah,
project?
see, better
Using some
accuracy
different-
was present because the entire image was selected. That's what I'm saying. But here, although my accuracy is less, but it is for only cancerous portion.
How you have decided this ISUP grade?
See, this ISUP grades are, actually these images, they were all, they were validated by a panel of 6 pathologists, okay, and 6 different pathologists with concluded that these images are fall under this particular category. These are validated images.
Okay, so this data set is present on
On
Kaggle,
Kaggle,
right?
yes, yes, yes.
Okay.
Panda challenge.
Okay. So
Yeah.
have you tested this on real-time data set? Whatever accuracy you have shown.
No, I have
89%.
tested on same the available data set only. The real data set I have not tested, because once I complete my entire this thing, then I will see for the real time data set. The entire data set which was available, in that only I have divided into training and test accuracy, not on real time.
Okay.
Yeah.
Okay.
Yeah.
On what basis you have decided that use of VGG16 only?
See, actually, VGG16 I have selected because one thing is that if you compare it with other or like ResNet 50 or EfficientNet or something, VGG16 basically generates feature maps that are easier to interpret. So that is basically essential for the pathologist to understand the cellular patterns. That was the reason this was selected.
Okay.
Yeah.
How many layers you have used in this?
See, in this basically 16 layers, I guess, yeah.
16. So how much time it is required?
To train the model, you're saying?
Yeah, train and test
See, I
everything.
did it on GPU on Kaggle. So Kaggle GPU was used. So it was done in 1 hour or so.
It's not possible in 1 hour.
Yeah, GPU was used.
Yeah, what is the specification of the GPU?
100 this thing, 100 GPU on Kaggle.
Okay, fine.
Thank you.
Yeah, thank you.
Thank you, ma'am, for the presentation.
Can I stop?
Yeah, ma'am. Up next, we have MD Russell Sarkar. He's presenting the paper titled Bayesian Optimization for Transformer-Based Load Forecasting in Australia. Sir, are you there?
Hello, sir. Yeah, I'm here. So, can
Yeah.
I share my screen?
Yes, sir. Now you can share your screen.
Can
Okay,
you
sir.
see my screen?
Yeah, sir. So I request you to finish within 10 minutes, okay?
Yeah, sure. I'm trying.
Yeah.
Hello, everyone. Good afternoon. This is MD Russell Sarkar from University of New South Wales. I'm here to presenting the title of Bayesian Optimization for Transformer-Based Load Forecasting in Australia. So,
Sir,
on behalf of my
sir,
yeah,
please
yeah.
start the slideshow. Present in slideshow mode.
Oh, sorry.
So present your presentation in slideshow mode. Sir,
So,
yes, sir. Fourth one. Select the fourth icon.
oh, sorry.
Yeah.
Yeah.
You can
So,
continue.
yeah. On behalf of my author, so I'm presenting this my paper. Just a second. Okay. So throughout my presentation, I'll cover this following topic: introduction, motivation, proposed method, and why I use the transformer, and result discussion and conclusion. So before I start that, so I need to know that what the time series forecasting. Time series forecasting is the forecast or predict the future value based on the previous historical value. It can be either single variant or single step or multi-step time forecasting. So single step only forecast only one value, and multi-step forecasting multiple value. So here in our study, I have done a multi-step forecasting. So load forecasting is crucial for energy sector because it help to predict the future electricity demand. So accurate load forecasting support the efficient, reliable, and cost-effective operation in power system. So there are some reason that why we need we need the forecasting, load forecasting in everywhere, not in Australia, is everywhere. So it's help to the efficient energy. So it's help to the efficient energy and generation and distribution, and it's also help to grid stability and reliability. So economic planning and demand and energy efficiency. So on. So there are some from the literature. There are some statistical model like autoregressive model, moving average model, autoregressive moving average model. They have some challenges. The showing the poor performance is the long-term forecasting. Also, it cannot be used as seasonal time series. So and there's some opportunity. Of course, they have some opportunity. There's standard benchmark of some techniques. So they needs a limited data set and successfully for univariate time series data set, where univariate means that only one variable. So So deep neural network network, they are overcome this challenges like traditional statistical model, but still the deep learning has some challenges like the poor performance is non-stationary data set or fixed input is required for training, and another is the main the long range dependency. They have long range dependency and unable to be trained in parallel. So the transformer architecture is the architecture that can overcome the deep neural network uh, challenges, but transformer some attention. So transformer have some challenges. Just as fuser, it's uh, the hard to their control the attention of the transformer. In also in any model, if you in the transformer there are lots of parameters. So if we optimize this parameter, so it's helpful to provide the good results like good accuracy. So why basically we select the transformer from the literature. We identify the transformer is a better accuracy for prediction because it's avoid the recursion and it's allow the parallel operation, and also intersequence is processed rather than the index by index. So in the right side, the figure 2 is our workflow of the transformer using the Bayesian optimizer for load forecasting, and the figure 1 is the just basic structure of the transformer. So I want to say something about the basic structure of the transformer. So basic structure of transformer is divided is consist of encoder and decoder. So important feature of the in terms of the encoder is a multi-head uh, uh, multi-head attention of self attention layer. So this is one who is basically trying to characterize the data coming into the system. This characterization is done through the variable key queries and value, and the main advantage of the transformer is self attention layer that allow to interact the inputs each other and find the which index pay more attention by the key queries and value. So this the pseudocode of the algorithm, and so here the results of our proposed result of our proposed model. So yeah, we basically use load forecasting, but for the better validation, we also use the electricity forecasting is the different. So also use the electricity forecasting with same models. But that so before I start that, so I explain about the data set. So this data set is this data set is two sets of data set. One is I already said the load, another is electricity. So first one is 5-year data sets 2006 to 2014. It has a 5 different feature, and second one is a 3-year data set, and it has 3 years. It is from 2016 to 2018, and so time is step. First data set was 30 minutes, and second one is 1 hour. So from the figure 1, from the figure 3, we can notice that the actual and predicted value from between the transformer BO is very close to each other to compare to others proposed model or LSTM and CNN BO. Similar to the figure 2 also is actual and predicted value is close to each other. So is there lots of data here, so we can visualize properly. So based on our next slide, like our results, so we can identify the our model is better than to others two models. So table 1 is showing that the hyperparameters and the sets of the hyperparameters, the base value of hyperparameters, and table 2 is performance indicators difference model. So from both data set, the transformer model is showing the better results to compare to others two models. So as a conclusion here, conclusion, so performance of the improvement is approximately 2 to 30% based on the different performance indicator. So also is a practical impact, so improve the grid stability, efficient resource allocation, better energy management strategy. So future direction will multimodal data set like weather, economic, social factors for consider for higher accuracy. So these are some references, and thank you. Any question?
What is dataset specification? Which dataset you have used?
So here I two data set I use. One is a electricity, another is a load. So both data set. First one.
Electricity dataset of what? I mean, of a whole your university or city or
No, it's I collected from the New South Wales state government is online, so they have opened their data set. So I collect this data set. The specific New South Wales specific zone, but they are not mentioned that zone. But is New South Wales data set like the state.
okay. So load dataset you just said that you have taken from 2010 to 16, right?
Yeah, but only they
And
have they
electricity you
provide
have
that.
taken from 16 to 20 something,
So
2020.
2018, yeah, 2018.
18. So why you have taken, why not you have not taken same time span data set?
Yeah, it's they provide that data set. That's why I taken that one. So I have because I'm looking
Yeah,
this
but
similar types data set.
to compare the result, you should have same data set so that you can say this is the load, actual load, and this is the prediction of electricity, right?
Yeah, you are right. So if on the other hand, we can say that the 5 year data set and the some more data set and some small set of data set. So both sector, so both condition, our model is better than to others two models.
Okay. So what is your analysis of this? As you mentioned in your title, it is forecasting, right? So
Yeah.
what forecasting result outcome you have given?
Uh, we just measure the accuracy that our model is for the like so can you repeat this question again? Sorry.
Yeah, you have said no in your title it is based on optimization for electricity forecasting.
Yeah.
Okay, so what is the research outcome in form of forecasting? What you're forecasting?
So we forecast the load to compare to based on the others 6 different feature like others we have in our data set. We first data set, like we consider the first data set, they have another 5 feature. So how much like that 5 data set also consider here. So we predict what is load forecasting based on data set. Also we also we want to show that the proposed model is showing the good accuracy to compares the others model that we mentioned in literature that okay, transformer has some advantage to compare the others model like LSTM and CNN. So we also make sure that okay, the transformer is better than to these two models.
Okay. Okay.
How many times you compiled this program?
It's initially it's not trial and error. We trying lots of time. Every time we get the best results. So our system is like our model is stable. That our yeah, our model is stable. Like we do 2, 3, or
How
4
many
times.
times?
So I make the 5 times here.
Only 5 times.
Yeah.
Thank you, sir, for the presentation.
Thank you.
So the next presentation is by K. Musadik Pasha. He is presenting the paper titled Beyond Loyalty and Betrayal, a knowledge graph enhanced RAG system for crime file insight and analysis. Sir, are you
Good
there?
afternoon, sir. Yes, sir. Am I audible?
Yes, sir, you are audible. You can start your presentation.
Okay. My screen visible?
Yes, sir, it's visible. You can start.
Okay. So good afternoon, everyone. I am Sadiq Pasha, a student researcher from PS University, Bangalore. It's an honor to present a research paper titled Beyond Loyalty and Betrayal. So let's get started. Films, especially in the crime genre, are not just entertainment. They are layered experiences filled with psychological tensions, evolving relationship, deep moral questions. But for machines, it's difficult. It's incredibly hard for them to understand it. What we are doing is our research sits at the intersection of NLP, knowledge representation, and narrative understanding. What we've done is we've developed a system that combines structured knowledge graphs with RAG to revolutionize how we analyze complex film narratives. As a data set, what we used for this thing is the Godfather movie. We used the entire movie script. So let me just spend a minute to explain why we have taken the crime specific movies. The first being the exceptional narrative complexity. That means the crime films are uniquely rich in narrative structures with deep character relationships, and these relationships evolve throughout the narrative. While characters like Michael undergo profound transformations, and the second being the thematic density. The themes being like power, tradition, family, etc. These themes aren't explicitly stated in the movie, but they emerge through the character actions and dialogues. And the third being the temporal dynamics, which includes the jumps, parallel storylines, and the causal effect and different stories across different scenes. These challenges are very hard for the LLM or matter of fact for the KRAG to understand. So that's why we have taken the crime movie films as our data set. So let's get into the problem statement. We all know that LLMs like GPT are powerful, they generate fluent responses and all. But the main disadvantage is that they hallucinate, that they make things up. When we bring this into the film domain, especially the movie Godfather, what we faced was the three unique challenges. First is the hallucination. The second was the knowledge update challenges. Traditional LLMs operate as closed systems after training, which means that we can't input another information into the system after it's being trained. Um, this makes them poorly suited for domains on which they are not trained. The third one being the weakness of the conventional RAG system. Standard RAGs systems, they primarily rely on the basic text matching and keyword based retrieval. While they can retrieve passages, but they struggle with semantic understanding and relationship comprehension, handling large narratives like the entire movie scripts, and the most important being the contextual relevance. That means they retrieve passages with keywords that are semantically irrelevant to the query content. And the last being the rigidity of the traditional QA. Traditional Q&A model, they require highly formalized and structured queries, which may not work for open-ended nature of narrative analysis. So here are the key objectives. The first one is enhancing the factual groundings and reduce hallucination, as I said before, and to support open-ended, non-factual based questions. The contribution of our paper, it is to develop the KG knowledge graph RAG pipeline, and we created a new data set, a question answer data set, because it wasn't available previously anywhere on the internet. And we've demonstrated the improved in semantic retrieval and contextual answer generation. So this is coming to the data set. Our corpus, as I said, includes the full movie script, which has all of this relationship. And for the testing data, we've used human annotated questions for non-factual question answers. This includes several query types that spans across different domains, which include inferential, comparative, relational, temporal, and dialogue analysis. The main part of our research was to benchmark the knowledge graph's ability to handle both fact-based and non-factual queries. Here's a snapshot on how our data set looks like. As you can see, there are 5 different categories, and each category has the question labeled with the ground truth answered by, yeah. So coming to the approach, okay. As you can see, this image illustrates how our KRAG answers the question in which let's say, in which city does Michael Corleone hide his murderers? Okay, by extracting, the first thing we do is extract the entities from the given question, which is Michael, Corleone, etc. Then we retrieve the full context. The first being the graph content and the vector database. Then we combine, then we fuse both the results. Then we pass it through the LLM for the to provide the answer for the question. Okay, now so here's our architecture. To tackle the above stated issues, what we did was, let's continue with the corpus preparation. The chunk size was 500 with a 50 token overlap to preserve the context, as the crime movies or have long sequences, and it's difficult to model the context if you lose the key characteristics. Then the graph construction. First, we extract key entities. Then we identify the just a second. Yeah, then we identify the relationship, that is family ties, etc., etc. Then we store the entire thing in the new 4G database for structured query support. Here's a snapshot on how the created knowledge graph looks. As you can see, the main actors of our movie, Don Corleone, Santino, etc., it's been recognized as the key influence, and all the different types of relationships are also extracted by our model. So coming to the next stage of the architecture, which is the hybrid retrieval. What we did was, we didn't just take the vector database, but we included the graph thing also. First is the graph-based retrieval, which includes full text search on the knowledge graph to extract relevant nodes and relationships from the graph, as you can see. Then the second part is the vector-based, which we use to analyze the semantic similarity search using document embedding. Then we combine both retrieval methods for an enhanced search for enriched context.
Sorry to interrupt you, sir. Your 10 minutes, 9 minutes are over.
Okay, let me just continue. So here is our configuration. Okay, coming to the results part. We have not only did it for like the normal answering. We have been included key performances like context precision, faithfulness, and answer relevancy, context recall, and semantic similarity. So we are checking it on these 5 things, and here's our results. Coming to the key findings, inferential query shows the strongest result with perfect context precision and high semantic alignment. The results show a strong precision in retrieving relevant context, while some metrics like answer relevancy and context recall may seem modest. This is because from our custom data set, which features semantically rich NLP questions with indirect phrasing, these nuanced queries often lead to answers that are different from the perfect responses. Okay, coming to the discussion for strengths of our origin, as you have already told, it's the hybrid retrieval part, complex search query, and allegation mitigation. Excuse me. Yeah, some challenges faced during the LLM, or like the parsing errors and the issues with the JSON input from the LLM. The summary, yeah, we've introduced the KG-RAG system for in-depth crime film analysis, enhanced narrative understanding through a novel hybrid retrieval mechanism. Here are the further steps. Incorporate multimodal input like visual scenes and all. Then explore cross-film analysis that can be done as a future part. Yeah, so the impact, like who is gonna benefit from this project or research? The first one being the AI researchers experimenting with multimodal explainable NLP systems with RAG, and the second one, content recommendation, which can use such analysis to model a non-factual thing, and for the fan communities for generating grounded and contextual answers. I appreciate your time. So yeah, that's my paper. Thank you. I'm open for suggestions. And so our generated data set is available at the Zenodo website.
What
Here's
made
the
you
link.
do this project actually?
Excuse me, ma'am.
What made you to do this project?
Yeah, ma'am. So when we looked at let's say knowledge graphs, they are good in retrieving factual based question. For answering non-factual and open-ended questions, there's no model available on the internet, and that too using crime movie films, it's not there. So to understand the deep insights and the overlying thematic relationships between the characters, we used both knowledge graphs and RAG.
What is your outcome of your project?
Yeah, ma'am. So the outcome is basically what we done is we develop a system which as I said, content as researchers or fan communities or even film educators can use to analyze the mm, deep thematic relationships which are not vital when you just watch the film. These things require deep insights of the
How
previous
can
thing.
how come film analysts, script writers, or digital humanities or researcher can able to read your journal paper and they can able to follow your concept and uh, your outcome will be accomplished? How do you think? Do you think a script writer will read your paper, journal paper, accordingly they use for their uh, thought process and they will implement in the future direction films or something like that?
No, ma'am. This is part one of the research. The next paper which we are trying to do is we deploy a system, as I said, which will include a, web-based GUI where any users, as you said, researchers or any of them can query, and it will ask our background system and get the answers on a web front end. So yeah, there's an interface, and we even developed a local this thing interface through which they can access. So it's not necessary for them to read the paper and get the analysis. All they need to do is just put a query for that specific film, and we get the deep insights and with the reasonings, with all the faithfulness, everything.
Yeah, normally it does no.
Yeah, ma'am. The issue with that thing is, see,
Yes,
as I
I
said before,
understood your project,
hallucination.
but
And
technically
it's
they
not
are
and
sound.
it
They can make use of your project. Like common man cannot use and understand your prototype, like what you
no, ma'am,
develop.
it's a web interface, it's a website thing, so where they can just put the text query
Do
question
you mean to
input.
say that all are well versed in making use of web apps and browsers and other things?
I didn't get your question.
Do you mean that all entire population are making use of web browsers, social medias, and other things?
Ma'am, when you look at the people who are working in the film industry, so yeah, they know all the workings of the web interface. So yeah, they would be able to navigate the website. So it's just a simple website with question and answering thing. So they shouldn't have problem with that. And you're answering your previous question, which was why can't just LLM answer that? The answer to that is our script, and the main thing is the script. The entire movie script is very huge, and the LLMs may not be trained, and even if they are trained, they hallucinate. They are not factual. So yeah, that's why a general LLM cannot do what they have done.
Okay.
And any more?
I have
Yes, ma'am.
some questions.
Yes, ma'am.
Anyone from film industry who is using your system, so how they will decide that which queries to be used? Because
Like
everyone is not so much trained that
yeah.
for
So
how many
here query means just a simple question in plain English. That's it. They don't have to know the background Neo4j database or any specific. Just like how we give a prompt to a chat GPT or you matter of fact for that Google, we just write our question, right? Similarly, all we have to do is put our question or our insight into the web interface. That's it.
Okay, so it is crime analysis. So if anyone just enter who is the suspect or something, so it will
Yeah, ma'am.
create
Yeah.
the knowledge graph.
Yeah, ma'am. In the background, what we do is we extract entities. Yeah, it will already the knowledge graph would have been created. It will take the important nodes and relationships from the graph, get a structured answer, and then give why it thinks it's a thing. To
Okay,
give
for
the
how
proper
many
answer.
movies you have tested this?
We tested it for 5 movies, but in the paper we have mentioned the biggest of them all, the Godfather movie, and we have chosen the crime domain because of the complex intricacies.
Yeah, so for 5 movies you have done this.
Yeah, ma'am. But the same pipeline can be extended for n number of movies.
Okay, and how you decided those factors, context and fairness and all these things? Because every movie may be having other factors also, right?
No, ma'am. These are our evaluation metrics, ma'am. These are the RAG metrics, like how we have F1 score precision
Yeah,
for
query
the.
type you have mentioned. No, query type is fact-based, inferential, comparative.
Yeah, ma'am. These are the different types of queries on which we have analyzed it. Like open-ended questions, dialogue-based questions, as you can see. These are just the type of queries.
Yeah, so only these types are
No, ma'am.
sufficient.
Like even if you give for general based questions or others, these are the main 5 query types where the LLM struggles. So we have mentioned these type of queries in our performance. If you
Okay. How
answer,
this
yes, ma'am.
how this query is related to faithfulness, context, and this one semantic similarity. These are the measures, but context is something different, no?
Ma'am, those are the metrics and these are the type of questions.
Yeah. So how we are relating this?
So what we wanted to do was we wanted to check how it does across these different types of queries on these metrics.
Yeah.
Yeah, so we are checking how faithfulness is the how faithfully it answers the inferential questions, how faithfully it does the comparative questions. So this is just the average of them. We have all these metrics specific for each of the query types.
Evaluation metrics are precision, recall, and all, like this way, right? Relevance. But what is
Yeah, ma'am.
context precision?
It's basically how accurately it extracts the context from the given question. And from the given, it extracts a key entity relationship and it compares that with the ground truth answered in our data set. So
Okay. So
it
your
basically checks.
context is related to all 5 query types, right?
Yeah, ma'am.
Okay. Fine.
Have you deployed your project?
Project, yeah, we are still yet to deploy it. Like the data set has been deployed. The project we are working on the web interface. We are making it
What
a
is the
little
size
more
of your
accessible.
data set?
It's the entire movie script. It's like 300 pages of the entire thing. Like if you go, we have sourced it from the IMDb website where you can go and get the script for each of the movies. It's the entire thing. Officially, it's there.
Each film is going to occupy how much storage and
Can you repeat the question, please?
you have stored 5 movies, no? Each
Yes, ma'am.
movie
Yes,
is
ma'am.
going to get stored in a memory. No.
Yeah,
So
ma'am.
what is the size of the memory?
The text file of the each of the movie thing is around 15 to 20 MB depending on the movie. Yeah,
Okay.
it took around 8 to 10 hours on multiple local GPUs on NVIDIA GPUs, NVIDIA 69.
NVIDIA GPU are you using?
Yes, ma'am. Yes, ma'am.
Do you have the GPU in your university?
Yes, ma'am. We used it from the research lab.
Is it available for all researchers to make use of it?
Yes, ma'am. So there's a formal process. You just go approach the teacher and you ask, we are doing such and such project. They'll
May I
allocate
know the
this much.
specification?
Huh?
May I know the specification?
Yes, ma'am. Here's what form. Just it was A1000 GP, ma'am. NVIDIA.
Okay, one last question from my side.
Yes, ma'am.
You have implemented this on movie, right? So movie is audio visual, but query is something you have to type in text form, right?
Yes, ma'am.
So from movie, how you are relating this? I mean, voice you are converting and then
No, ma'am. We were taking the yeah. That's why we are doing it on text, right? So we are taking the movie text. So movie, as you said, there's the video part, there's the image and audio visual part. There's even the movie script, which gets developed before the movie gets created. So first, the director writes the script. So on the entire script, we're generating the knowledge graph.
okay. So are you taking that audio visual both and text also?
No, ma'am. The audio and the visual or the further
Because
enhancement. Those were.
sometimes in movie, what happens? There is no,
Yeah,
I mean, text is there, but something is going on, right? Visual part
yeah,
is
ma'am. Those
that
things.
crime is
Yeah, I
being
get your
happening.
question.
So yeah,
Those things are mentioned in the script. Like as a this script is not necessarily the subtitles. Subtitles are different. The script contains all the audio description. Like let's say there's suspenseful background music going on in the script.
yeah.
The thing has been written. Like okay, after this dialogue has been said, there's a suspenseful background music and the music name, everything. And let's say there's an action scene, and let's say a bullet founds the bullet burst and all. So those things, all the audio descriptions are also the main things are also included in the script. Those are there in the script.
Okay. Yeah, that's it from my side. Thank you.
Thank you.
Okay, thank you for the
Can I
presentation.
stop presentation?
Yeah.
Yes, thank you.
Up next, we have Gray Zimbabwe. He's presenting the paper title Enhancing Disease Outbreak Forecasting, Integrating Environmental Factors, Policy Interventions, and Machine Learning in Hybrid Epidemiological Models.
Hello, good afternoon.
Good afternoon, sir. So you
Okay.
can present your screen now. It's my humble request to everyone, please stick to the dedicated time limits, please. Yes, sir, it's visible. You can start your presentation.
Okay, and I'm audible, right?
Yeah, you are audible.
Thank you. Okay, good afternoon, everyone. My name is Grace Chibawe, as stated, and my co-author is Dr. Mayumbo Nyirenda. We are both from Zambia, but different universities. Our paper is entitled Enhancing Disease Outbreak Forecasting, Integrating Environmental Factors, Policy Interventions, and Machine Learning in Hybrid Epidemiological Models. The outline is as presented. We'll run from the research background down to the references. I'll not dwell much on this one for the sake of time. Epidemiologists would be familiar with SEIR in modeling. This is a common model, the classical model that is used in forecasting disease epidemics. And most of the models done are actually classical, the ODE models, that is ordinary differential equations models. Now, the background to this research, these epidemiological models like the SEIR have been essential in disease modeling. They've been very helpful, but these models often overlook other factors because they cannot integrate other factors like environmental and policy data. Then machine learning offers a solution to this, but on its own, it lacks epidemiological grounding because the SEIR classical models have epidemiological grounding. Therefore, this research is there, or can I say there's need for hybrid models that integrate the mechanistic features of the classical models and the data-driven techniques of artificial neural network or machine learning. The purpose of this research was to enhance accuracy of infectious disease forecasting using hybrid SEIR and artificial neural network model. Now, this research is a part of an ongoing research that aims at improving accuracy of disease forecasting. So this particular research it integrates environmental and policy intervention variables into forecasting. And then the baseline models, that is the classic model on its own, the AN model on its own, and the ensemble, that's the hybrid models, are evaluated. The literature that we went through, if I may put a summary to it, we find that there has been papers that look at, say, the SEIR model plus environmental factors, but do not integrate machine language. Then there will be another paper that also will lack the integration of environmental or machine language integration when it just looks at a classic modeling. Then we also have a paper that looked at the classical model plus social distancing, that's the policy management, but did not include machine learning. Then this Spanias et al., not Spanias, it's Chen et al. In 2024 looked at the hybrid modeling, but would like to have this contextualized to Africa. In the methodology, first of all, we looked at data collection. The data that was used for this particular paper was COVID-19 data that ranges between 2020 and 2023. That's in Zambia, the surveillance data for Zambia. And this was collected from the official website of the Center for Infectious Disease Research in Zambia, the Centers for Disease Control, and the WHO. Of course, the Zambian Ministry of Health website had some data, but not very consistent. Then the environmental data was collected from an open online repository, that's visualcrossing.com. The data that was collected for environmental was rainfall data, the temperature data, and humidity to integrate in the modeling. The missing values in the data were replaced with zeros. The missing time steps were replaced with zeros for the purpose of mathematical calculations. The tools that were used, the visualization and simulation utilized Python libraries like the NumPy, SciPy, TensorFlow, and many others that are very good for epidemiology. So Python has a rich library, open source library for epidemiology. This led into the development of the baseline models, that is this classic SEIR model, the transformer-based NN model, which were compared against the hybrid model. And these three were compared also before the integration of environmental and policy data and after the integration of that data. The split of the data, 2020 to 2022 was used for training, and 2023 was used for prediction to test the model. Then the root mean squared error, mean absolute error, and R squared were used to evaluate the models to check accuracy. The root mean squared error penalizes larger errors more than the others, and so we leverage more on it than the other two. I jump straight to the results. So the SEIR classic model, the baseline model, remained stable before and after the inclusion of the environmental and the policy variables. We ran these models at 100 epochs and also ran it at a higher number of epochs, 200, just to check the performance. The higher we went, the more accurate the ensemble models were. The enhanced artificial neural network model outperformed the baseline artificial neural network model at 200 epochs, and going from 1,943 of the RMSE to 546. For RMSE, the lower the value, the more accurate the model is. Then the ensemble model yielded the highest accuracy of all after incorporating the environmental data and the policy. This running from 843 before the incorporation of the environmental data and the policy to 361 after the incorporation. So the results confirm the benefits of hybrid modeling in data-limited regions like Africa, especially Zambia, where data is so scanty, the data collection is scanty. This figure is just showing the output of the Python code that we used. On the left-hand side, that is before the integration of the environmental and policy data. And on the right-hand side, that's after the integration. And you can see after the integration how close it is to the blue curve, which is the actual data of COVID-19 2023 in Zambia. So like I said, we worked more with RMSE, and you can see here in blue, when we added the environmental data, improved, the RMSE went down to 361. So in concluding, I would say the SEIR models are accurate but limited in handling real-world complexity, as confirmed by Sinkala and others in 2020. Artificial neural networks are flexible, but they risk overfitting sometimes without mechanistic structure. So the ensembling helps to reduce overfitting. And of course, the environmental data itself also helped to reduce the overfitting. And the testing of data on a different data set also helped reduce overfitting. Hybrid models combine strengths and adapt well to real-time external drivers, according to Chain 2024. So this has been proven by this, the result of this research. So we recommend for hybrid integration in epidemic decision support systems whenever epidemiologists are modeling for disease forecasting. So we recommend that hybrid SAR and artificial neural network models are developed and deployed for forecasting frameworks. And we also recommend the integration of environmental and policy variables in epidemic planning from this research. And we promote the use of open source tools, especially even in school settings or student settings, because they are rich libraries that can be used and even to enhance fast predictions because of their availability. Then one other thing is these expert systems sometimes do not receive adoption because of the complexity of the background. Therefore, we recommend that ICT experts, the computer scientists, develop platforms which epidemiologists can just feed in data and use so to encourage adoption and so that prediction can be done faster than just using classical modeling. Some of the references that were cited are there. Thank you very much. And I'm open for improvement suggestions.
How many parameters you have taken in your data set?
So, sorry, come again?
How many parameters you have taken in your data set? You said environmental is there, policy is there, and
yes, so
outbreak data set. So how many different and which are those?
So we had the disease data set itself, then the rainfall. In the environment, we had rainfall, humidity, and temperature. So we are using the maximum of these because of the relationship with the disease. And then policy, you know, when there's a policy pronunciation, you say maybe schools are closed or anything like that. So that was the fifth one.
Okay. And you have used ANN for training, right? Model. ANN you have used.
So transformer based, yes, ANN, yeah.
Okay. Okay. Yeah, that's it from my side.
Sorry?
No questions.
Thank you.
Okay, sir. Thank you for the presentation.
Okay, thanks a lot for giving me the opportunity to present.
Yes, sir. Welcome. Up next, we have Qazi Zebural Islam Nafi. He is presenting the paper title Navigating the Tech Landscape Career Counseling for Aspiring Computer Scientists. Qazi sir, are you there?
Hello.
Yeah.
Are you listening?
Yeah,
Yes, I'm there.
okay, so you can start your presentation.
Thank you. Hello. Our project is the Navigating the Tech Landscape Career Counseling for Aspiring Computer Scientists, and we have 3 members in our group. They are contributing the project equally, and we face some challenges, yeah, in the current decision making in our basic. Yeah, we made our BSc and we took a miscalculation in the next part. So we tried to create a counseling for that area. First, it's empowering the individuals. They are making many mistakes, so we have to solve their misunderstandings and give them a right path for that. Yeah, our basic career have diverse career path in that way, and we don't know many of them. The lack of standardized data sets and and dynamic job market trends, data models. And our approach is to the collect data and pre-processing. We collect the data from online Kaggle, and we pre-process the data by feature engineering, and we select some various kinds of models and the hybrid and assembles techniques also. And this is our experimental design. It's a model for our project. For our project, and we took some review for our project. And also there are many paper we read in terms of that. And the data set, our data sets key features are projects, CGPA, specific courses, research experiences, extracurricular activities, internship, and coding experiences like C, C++, C, C, Rust, and other software development courses like HTML, CSS, React, etc. And we also took some communication skills and teamwork in the dataset also. And this is our encoding, and we took some binary and mapping for some of our features, যেমন course network, coursework completion status, internship experiences, certifications, training and leadership experience, and ordinal encoding for academic achievements. And some of we use one cohort encoding, and some of them are using level encoding for career goals. And we use random forest, SBM, K nearest neighbors, logistic aggregations, AdaBoost, and XGBoost, and gradient descents, and decision tree for our model. And this is the results of our models. The XGBoost took 88% accuracy overall, and F1 is 88%, a micro average precision 88%, and recall is 88%. And these are the other models accuracy, decision tree, random forest, and nearest neighbors. And the key features of these models and decision trees and top features is technical skills for Ruby, CH, and random forest's top features is common technical skills, JavaScript, and XGBoost is soft skills and experience. And influence focus on for free. These are some limitations. And we relied on data that and incompetent and biased data sets can affect predictions. So we implemented some of our technique for so there is no bias in our data set. Struggle with developing job market trends and dynamic requirements. It is very necessary for our BSc students. Feature, it can be expanded also because we use an online data set and took to the 88% for XGBoost, and some people also took the data set and create more diversity in this path. And the conclusion is this is a novel contribution. We introduced this data set. Yeah, we work the career for many students for their future work, and we will have to work patiently for their to resolve. And thank you. You may question. Hello.
Yeah, you have shown XGBoost is having better accuracy.
Yes, sir.
Yeah, but in another slide, you have shown that XGBoost is giving top feature as soft skills, and this is for computer science people, right? So
Yes.
so it is, I mean, conflicting, no? Then both of them.
And this is our code for XGBoost, and I all the types are equally matched. Just some percentages is necessary. Difference is exact. Well, we just
Have you identified different career paths under computer science only?
yes. We only work with BSc students for that. there is
Because in your title you mentioned it is only for computer scientists, right?
yes. We only work with the computer science students or
Okay.
only BSc
So,
students.
okay. So how many paths, career paths, any number of paths you have identified?
30.
30. Okay. But in result, I have not seen anywhere that it is showing for this path, this is the prediction.
This is not here. This is, I think, we predicted the next how to work with the he achieved more to work next type. Like if he want to be with BSc student, BSc career, then how much he could carry on. If he work with the BSc, then this is 88%. Like our data set is about BSc student only, so there is only BSc curricular related. So we want have to BSc. He is work with BSc. Next is CSC career path or other. If he is the percentage is higher, then he is actually the BSc career in this his path.
Okay.
Is
Okay.
it a expert system which is used for career counseling?
I don't understand the question. Please repeat it.
Is this the expert system which provides decisions for career counseling?
Yes.
I haven't noticed any career counseling in the output or in the discussion. Okay, in order to provide a career counseling, what is your accuracy and satisfaction level of the user who seek for career guidance here?
We did not deploy that data in this. We just work with the predicted how to he want to be a computer engineer or other than that.
Okay.
Any more questions, ma'am?
No.
Okay, ma'am. So you can stop your. Thank you, sir. Up next, we have Hasin Eshark. He is presenting the paper title Para Motion, a comprehensive paralysis health and therapy system. Hasin.
Hello.
Okay, sir. You can start your presentation.
Yes, am I audible?
Yes,
Can
sir, you are audible.
Okay. Let me share my screen. Is my screen visible?
Yes, sir, it's visible.
Okay. Okay. Good morning, everyone. My name is Hasin Ishraq. I am a final year student at Independent University, Bangladesh, enrolled in the Department of Computer Science and Engineering. It is an honor for me to present my research paper on paramotion, which is a comprehensive paralysis health and therapy system at the 9th International Conference on ICT for Intelligent Systems. This work is a collaborative effort by me and my 4 supervisors named Ataur Rahman, Tarek Habib, Sabrina Alam, and Mahdi Hassan, which is conducted at Fab Lab, which stands for Fabrication Lab. Today, I'll walk you through our research, highlighting the challenges in paralysis care, our proposed solution, and its impact. Paralysis patients faced immense challenges, including limited mobility, difficulty communicating, and a lack of real-time health tracking. What about current systems? They're fragmented. Some track vitals, others focus on rehab, but none combine all the three. This disconnects, delays emergencies, and slows recovery. Imagine a caregiver missing a fall or a patient struggling to ask for help. Paramotion was born to solve this. Here's the breakthrough. Paramotion integrates real-time health monitoring with medical-grade ECG and fall detection sensors, automated rehab via a smart glove, and emergency alerts with a 99% reliability. It even lets non-verbal patients communicate through hand gestures. Think of it as a Swiss Army knife for paralysis care, which is compact, affordable, and unified. What about the existing tools in the market? They're like a puzzle pieces that don't fit. Some track heart rates but ignore falls. Others offer rehab gloves but lack alerts. Worse, many fail in remote areas due to poor connectivity. Paramotion bridges all these gaps by combining all the sensors, the rehab tech, and dual GSM plus Wi-Fi alerts, all on one platform. No more fragmented care. Let's take a peek under the hood of the system architecture. Sensors like ECG and accelerometers feed data to a microcontroller. If a fall or irregular heartbeat is detected, alerts fire via the GSM or cloud apps. The rehab glove activates in 2 seconds, guided by the flex sensors. All are powered by a lightweight battery. It's not just safe, it's fail-safe. Here you can see the architectural design. Left is the block diagram, and the right one is the complete hardware layout in a virtual simulation. Paramotion's strength lies in its 5 integrated features. First, its health monitoring system uses medical grade ECG and temperature sensor alongside an accelerometer to detect falls in just 4.5 seconds, assuring no emergency goes unnoticed. Second, the smart rehabilitation glove automates hand exercises, activating in 2 seconds and demonstrating a 40% improvement in mobility over a period of 30 days. Third, the emergency alert system boasts 99% reliability, leveraging both GSM and cloud-based notifications to work even in low connectivity areas. Fourth, the flex sensors enable gesture-based communication, empowering non-verbal patients to express needs like hunger or pain through simple hand movements. And finally, a dedicated caregiver dashboard provides real-time health data and trends via web or mobile apps, enabling remote adjustments to therapy. Together, these features don't just address symptoms, they restore independence and dignity. Let's take a look at the results. Does the system work? Absolutely. Sensors respond in 4 to 6 seconds. The glove showed 40% improvement in hand mobility. Caregivers rated it 92% for usability. And what about the patients? 85% of them found hand gestures life-changing. Even with the 3 to 5 second cloud delay, emergencies never slip through. This isn't a prototype, it's proven. Compared to the rivals in the market, Paramotion is the only system offering all the 5 key features along with other features. Other cost 3 times more or lack critical tools like gesture control, gesture communications. Take Jacob's exoskeleton, no alerts. Go's glove, no health tracking. Paramotion isn't just better, it's essential for holistic care. Now, no system is perfect, neither is mine. Connectivity can lag in remote areas, so we're thinking of adding a 5G and a solar power. Sensors need calibration. We're thinking of integrating AI into it, and AI will fix that. By the end of 2025, predictive analytics will forecast strokes before they even happen. And what about costs? We'll slash them by 30% with open source tools. At only 18,500 Bangladeshi taka, which is roughly equivalent to $170 US, Paramotion costs 70% less than its competitors. The sensors take up 33% of the budget, the glove 19%. No subscription, no hidden fees. If it is produced in bulk, it will cut another 15%. Affordable care isn't a luxury, it's a right, and we're delivering it. Paramotion isn't just tech, it's hope. Hope for patients to regain independence. I hope caregivers act faster. I hope clinics cut costs with AI upgrades and global scalability. We're trying to redefine paralysis care. Thank you. Let's build a future with where no patient is left behind. These are the references that I use throughout my presentations. That wraps up my presentation. I'd love to hear your thoughts or questions.
Is the product available to bring in the market?
Hello? Can you
Hello?
repeat the questions, please?
Yeah, is your system or product is ready to bring in market?
We're working on the outlook of it. It's not yet ready. I hope it will be ready within the next 3 to 4 months.
Okay, so it is hand glove is ready, right? Because
yes, the hand glove is ready.
Okay, and what AI? Why AI is used?
AI is not used here. It's a recommendation to use for the future on the sensor calibrations. for the sensor
Okay.
calibrations.
Okay. So through Glove, we are taking that sensor values, right?
Yes,
ECG and all these.
yes. All the sensors will be connected on the glove.
Okay. And alert system, so it will not take AI, I mean, use AI for fault detection and everything.
The coding that we did on the microcontroller, it's pretty much accurate, like almost 95% accurate. So I don't think we need the use of AI on the emergency alerts.
Okay. So because here somewhere you mentioned no integration of IoT and this thing.
Yes, ma'am.
Machine learning. Yeah. So IoT, where it will be used? I mean, only that glove is connected to your system, right?
Yes,
Okay.
it's used for sending real-time health monitoring that can be monitored on a mobile app for the which is for the caregiver.
Okay. So have you done somewhat kind of testing? Because as you said, only glove is
Yes,
ready and
yes. Surveys had been done, conducted with roughly around 35 paralyzed patients on
okay.
different hospitals across Bangladesh.
Okay. Para analysis, so it is related to only your hand motion, right? It is not, I mean, whole body if it is paralyzed.
We are targeting a community only for the hand gesture communication, that the hand and only the four fingers will not be paralyzed. We're
Okay.
targeting those audiences.
Okay, fine. So somewhere you need to change in your title.
Yes, we
Be
do need to
specific,
change.
yeah.
There's always room for improvement. Yes.
Yeah, that's it. That's the suggestion from my side.
Okay. Thank you.
Yeah. Thank you. Great work.
Thank you. Thank you so much.
Are you going to apply after 3-4 months after completing your entire work to another journal?
Can you repeat the question, please?
After completing, you said you are going to complete your entire project after 3-4 months.
Yes.
Are you going to apply for a different journal after completing your work?
Yes, we are also thinking of that, as my supervisors advised that. Yes, we're going to do that, hopefully.
Okay.
Is there any more questions for me? I think there isn't. Thank you, everyone. Thank you for listening.
Yeah. Next, we have Sobus Alex Francis. He is presenting the paper titled SOG RNN Controller for Path Planning Module of WMR, Real-Time Adaptation and Navigation in Outdoor Environments. Sir, are you there?
Good morning, everyone. Can you hear me?
Yes, sir, you are audible. Just a second. Yes, sir. Now you can share your screen.
Yes. Okay. In this session, I'm Dr. Sobus Francis from Abu Dhabi Polytechnic, Abu Dhabi, United Arab Emirates. Today, I will be presenting our work on a novel control system for mobile robots titled Self-Organizing Generalized Regression Neural Network Controller for Path Planning Module of Wheeled Mobile Robots. Real-time adaptation and navigation in outdoor environments. This research is focused on enhancing the adaptability and intelligence of mobile robots operating in complex outdoor environments. Let's begin with the basics. A path planning in outdoor environments is particularly challenging due to the unpredictability of real-world conditions. Factors like uneven terrains, dynamic obstacles, and lack of reliable maps make navigation a complex task. Traditional controllers are often not sufficient because they lack the ability to adapt in real time. So, our goal is to create a system that not only navigates efficiently but also adapts intelligently to its surroundings. We were motivated by the limitation of conventional methods such as PID and fuzzy logic controllers. These systems often require manual tuning and do not adapt well when the environment changes. They perform reasonably well in structured indoor settings, but struggle with the complexity of outdoor scenarios. This led us to explore a learning-based approaches that can evolve and respond dynamically. Our approach integrates a generalized regression neural network or GRN with a self-organizing mechanisms. The resulting controller, a self-organizing GRNN, is capable of learning the non-linear relationship between input, mostly from the sensors, and commands, or I can say navigational commands to the robot in real time. By using self-organizing principles, the network can modify its structures by adding or removing neurons based on the complexity of the environment. Let's talk about a self-organizing GRNN. As I said, it's based on a known model, which is a GRNN, which is good at prediction. What we added is the ability for the network to grow, reorganize, and adapt as it gains more data. In simple terms, it becomes smarter as it learns from experience. This slide shows the architecture of our controller. That means they have an input layer, receives data from the sensors, such as obstacle distance, heading direction to the goal. This information is processed using a radial basis function units, which allow for smooth generalization. The output layer produces control commands like linear velocity or steering angle that will be used by the mobile robots. This setup enables the robot to move efficiently towards its goal while avoiding the obstacles. The key innovation in our system is the use of growing neural gas algorithm. This algorithm allows the new network to evolve its topology dynamically. If a region of the input space is not well represented, the network adds new neurons. It prunes neurons that are no longer useful. So this features ensures the network remains compact and efficient while still being capable of handling new and complex situations. So our algorithm's learning mechanism is inspired by the reinforcement learning principles. Um, the network updates its weight based on a real-time error functions, which evaluates the difference between the desired and actual robot trajectories. When the robot performs well, the network reinforces those pathways. When it performs poorly, the network adapts its structures and weight to improve. So this continuous learning loop allows the robot to handle unexpected obstacles or changes in the environment. To test our algorithms, we implemented the controller on a wheeled mobile robot that is equipped with LiDAR sensor, a GPS module, and onboard computing. And we also did some simulation-based testings. So this robot was tested in an outdoor terrain that included grass or gravel and small obstacles like rocks and some poles. So these conditions were chosen to reflect the kind of unstructured environments robots might face in real-world applications. If you take an applications for in agriculture field, surveillance or search and rescue operations. So these environments where the path is not fixed and things can change often. Okay, so these are the two different types of mobile robot platforms. We tested our algorithms on four-wheel and then this like two-wheel mobile robots. And this show the flow chart of how this how the goal position and how this ROS-based navigation package is used and our algorithms is used to follow the trajectories or to generate control commands to the a low level controller for the mobile robots. So in our experiments, this self self-organizing GRN controller enabled the robot to navigate smoothly and reach the target location efficiently. It avoided obstacles without needing a preloaded map and was able to respond quickly to changes in the environment. So we measured
A
metrics such
reminder,
as
I have
time,
around 9 minutes
goal,
over.
path smoothness,
Okay.
obstacle avoidance success rate, and found that our algorithm outperformed traditional controllers across the board. So we have this some videos where we of our experiments. Start with the we ask the robot um, follow a square path. Mm, Then we ask the robot to follow a circle path. Then the circular path with some uh, morning everyone. Code manual tuning. Additionally, while it works well in a moderately complex environment, it hasn't yet been tested in densely crowded areas or among fastly moving objects. So our future work, so to summarize, so our controller we develop provide a naval and effective solution for adaptive and real-time navigation in outdoor environments. His ability to self-organize, learn, and continuously makes it highly promising for future robotic systems. Thank you very much for your attention.
What are the challenges you faced while you are
So our
implementing this
future work,
project?
and thank you for listening.
Yes.
What are
Yes.
the challenges you faced when you implement this project?
The challenges we faced is, as I mentioned, this is a real-time project. That means we would like to implement this algorithm in a real-time robot. Especially, we have used robotic operating system. So, as I said, usually you said neural networks need to be trained offline, and the idea of this algorithm is we want to do it online, getting the information from the sensors, and then process it, and then send it to the ROS packages where they do the control. So we place some issues on hardware, but we are able to manage to get this algorithm working online. As you said in the videos, we have done some experiments real time, so that it can follow the trajectory what the path planning algorithm or path planning package is going to provide. The idea of this algorithm is, as you said, tuning a neural network. That means getting a gain value, exact gain value is the challenging task. So this self-evolving algorithm can get exact neural net value for each systems. So we have implemented on 2 different mobile robots, which I have showed in the slides. One with 4-wheel mobile robot, which is, and another one is a 3-wheel or 2-wheel differential mobile robots. That's the challenges we faced.
Is this autonomous robot or controlled by
No,
some controller for some system?
No, this is autonomous robot. The main idea is autonomous, fully autonomous.
Okay. So obstacle, how it is capturing obstacle? You have shown that it is. I mean, you have tested how many types of obstacle?
So we have tested both static and dynamic obstacles. As you said, we have used LiDAR sensor, which is which will provide a depth value, not just traditional normal camera. It will provide a depth value. So from the depth value, it can the path planning algorithm can generate a optimal path, avoiding the obstacles. So that's how we have used plenty of different size and shapes of obstacles during our experiment.
Okay. So what is your point of perspective? Like you have implemented this autonomous robot system.
You say my objective for this is like the future work would be we want to test it in different robots, for example, humanoid robots or legged robots. The idea is the system has to be intelligent enough, the controller has to be intelligent enough to behave as per the environment. So
yeah, but have you considered any specific application of this?
Application, as I mentioned, it is application for search, surveillances, or exploring a new area, or without any map available to this robot. So for example, Mars exploration, so the area we don't know about. So this algorithm can help in provide a right controller for the system.
Okay. So that you have mentioned that future work, you are not tested it in crowded area, because in crowded area there may be different scenario, many kinds of obstacle will be there.
Yes, that's the idea, because we have right now we have in an open ground with limited obstacles. When it is crowded area, like we need to have more computational system or hardware, we need to adapt.
Okay, good luck for the next thing. Thank you.
Thank you.
That's it from us.
Thank you, sir, for the presentation.
Thank you everyone.
Up next we have Selena Rosado Briones. She is presenting the paper titled Systematic Literature Review on the Use of Cognitive Platforms in Teaching.
Hello, everyone. My name is Elena Rosado. I am from the Technical University of Manabí. It's a pleasure to be part of this cognitive systematic literature review of views of cognitive platforms in teaching. This student seeks to contribute to the David of the use of cognitive platforms to begin. I will provide an introduction to the context and background of the research. Okay. In the educational field, teaching programming presents considerable challenges, particularly in adopting methods that are both effective and personalized for each student. Cognitive platforms emerge an innovative response to this as they combine artificial intelligence and machine learning algorithms to transform teaching and learning process. The purpose of this study is to conduct a systematic literature review, employing the PRISMA methodology and agility to three purpose phase: planning phase, discussion phase, and analysis phase. Planning phase. The three research questions were formulated to understand how it is transforming higher education with an impact on motivation and learning. Also, exclusion and exclusion criteria were established to select relevant students. In this study, keywords were used to formulate two research questions related to the impact of using cognitive platforms in programming education for engineering students. The questions are as follows. As one, how does the use of cognitive platforms based on artificial intelligence impact the academic performance of programming students? Question 2, what are the main challenges and opportunities students face when using cognitive platforms to learn programming? Question 3, what benefits are obtained by integrating cognitive platforms into the programming teaching process compared to traditional learning methods? The focus in reading journal articles published between 2019 and 2024 in English, Spanish, and Portuguese. Exclusion criteria in this card population lately scientific research in a thousand documents duplicates of studies that address topics unrelated to the research objective. This search and selection protocol enables the discovery and selection of the most relevant documents for student subject matter. For each of the consulted database, the total number of reading articles were recorded and sequentially a selection process was carried of the identify those that meet the probabilities established, inclusion and exclusion criteria. After the application of the criteria, a final set of 40 students was obtained, all of which satisfied the requirements for inclusion in the student. Analysis phase, with the data extracted from the final selection of students, various analyses were conducted focuses on the use of cognitive platforms in the programming education. These analysis include IA and machine learning and programming to apply the educational programming environment, highlighting how these tools can enhance learning and understanding of complex concepts. A quality assessment was applied to each of the selected students to ensure the relevance and quality of the results. In the result section, the research question address demonstrate that the use of technologies can optimize both cognitive performance and students. Self-regulated learning capacity. Furthermore, in the show that the platform can facilitate learning activities at different educational levels and strengthen perfection skills, contributing significantly to improvement of educational process. As one, how does the use of AI-based cognitive platforms impact academic performance of programming students? AI-based cognitive platforms have transformed programming learning by offering personalization, accessibility, and efficiency. Moodle, for example, adapts learning paths according to student needs. Although its managing can be complex, intelligent tutor system provides personalized tutoring and immediate feedback, optimize learning, but overuse can limit independence. Auto-grading system, such as Gradescope, auto-A assessment, reducing teaching load, although they don't always detect advanced logic errors. MOOCs such as Coursera democratize access to quality content, but the lack of interaction can lead to isolation. Tools such as Khan Academic and Newton personalized learning, also the effective, districtly and advanced lens in terms of optimized intelligent tutoring system and Moodle, Excel and personalization will escape and code or and useful for managing Jupyter notebooks or auto-graded system of the solid technical support and plan for slide, RedPig on Coursera facilitate learning.
Sorry to interrupt you, ma'am, but your time is up.
Question 2. What are the main challenges and opportunities faced by students when using cognitive platforms to programming? Visual programming platforms such as Scratch and Code.org facilitate initial learning with playful approaches, ban and hinder the transition to visual language or solid foundation in the established. Question 3. What benefits are obtained by integrating cognitive platforms into the programming teaching process compared to traditional methods? The integration of cognitive platforms into programming education brings relevant benefits compared to traditional learning methods. These platforms allow for the personalization of the educational experience, tailoring content activities to each student pace and level. Conclusion, this student aim to analyze the impact of cognitive platforms on programming education and emphasize the utility, benefits, and the challenges they present in current educational environment. Thank you.
Okay. Selena, so what is your future perspective? I mean, how you are going to use this analysis in your future work?
However, several challenges associated with the adoption were identified. This includes the Java implementation, cause the lack of the adequate teacher training to effectively use this tool, and raising children in the center educational system.
Okay. Yeah, that's it from my side.
Okay.
Through your project, did you get any feedback or have you shown this outcome to anywhere else for getting some comment about your project, anything else? Because it must be useful to the researcher where they are going to use your project actually. So have you done like that, anything?
The cognitive platform serve as transformative tools in program education, their ability to personalize the learning experience based on individual student needs, provide real-time feedback, and adapt to in learning pace contribute to improving academic performance.
Thank you, ma'am, for your presentation. Up next, we
Okay.
have MD Russell Sarkar. He is presenting XAI explainable AI approach for SPF using CNN LSTM attention model. So are you there?
Yeah.
Okay, sir, you can start your presentation.
Can you see my slide?
No, sir. Yeah, it's visible now.
Hello everyone again. So now I'll present the title of the explainable AI approach for solar power forecasting using CNN LSTM and attention model. So it's a hybrid model. So throughout presentation I'll cover this following topic. So reliable solar power forecasting is essential for effectively integrating managing solar energy system. It's crucial because of its help to manage and integrated solar energy into power grid more efficiently. So in addition, the accurate solar power forecasting ensure efficient uh, grid operation, reduce cost, and prevent the reliable issue that suddenly change the solar generation. So, however, the conventional forecasting method encounters challenging when they address high complexity of non-linear nature of solar power generation data. So, for this challenging for the addressing the challenges, so we'll introduce the a hybrid model for overcome the conventional problem of this solar power forecasting model. So earlier we talk about the challenges of the statistical model that overcome the deep learning model. So each deep learning has some uh, challenges. So like convolution CNN convolution neural network, so that has a unable to capture long range dependency. So and another the LSTM model to struggle the capture details of the special feature of the local pattern, and another one the attention inherently extract the comprehensively special or the temporal information independently. So is challenges we combinedly when we combine the three models, so that it will help to overcome this individual challenges model. So a hybrid model. In this study, a hybrid model that CNN LSTM attention, uh, which combined and combined with the CNN that able to extract the special feature, and the LSTM have strength that in capturing the temporal pattern and the final of the attention. So that mechanism help to focus the significant time step in enhancing the interpretability on the performance. Moreover, moreover by we in this study we introduce a feature evaluation feature evaluation of explainable AI that help to identify the which features are more important to a more important impact factor to driving the prediction and gain the good accuracy. So this is our proposed model. The solar data pre-processing process, then convolution, the max pooling, then LSTM attention, and finally the fully connected layer, and then finally solar power prediction. This is a block diagram. So next slide, the pseudocode of our proposed model. We in this study we use a two data set. This data set is defined as the solar station one, which is 50 megawatt capacity, and second one 130 megawatt capacity. So first solar station data set collected from both are collected from the China. So it's a 2-year length, 2-year length of the data set, 2019 to 2020. So and is the time step of the data set is 15 minutes interval, and the total data set for both data total time step of the both data set is 70,176. So the first data set is showing the first data set sorry, figure 2 showing the first data set results with actual and prediction results of the three different model. So and second data set showing the actual and prediction results of the proposed model, the hybrid CNN LSTM attention. So from the both figure is actual and predicted result, predicted data set is very close to each other. So here is the statistical analysis of solar power. So site 1 and site 2, the mean maximum minimum standard deviation. So for both data set, and the table 2 is the performance indicator of two data sets. The first one is our proposed model XAI SP is showing better results to compare others. Others for indicator MAE, MAP, and RMS are coefficient generation R square. So for the both data set, our model showing the better results to compare the traditional model. So this is our the explainable AI feature evaluation study. So in every data set we use six feature. So for the data set 1, so solar radiation is show the more impact, uh, and second one is the atmosphere. So similarly the figure 2 solar radiation showing more impact, and the normal and direct normal radiation of is second impact of the feature, and third one is global horizon of solar radiation. So from this figure we can identify that which feature is more important, like for the like if which feature is more put the impact on the results of solar power forecasting. So finally, our proposed model is improvement 8 to 34% based on the all four performance indicator, and the explainable AI explainable is showing the interpretability and the trust in the model prediction, and future direct expand the more location and implement real time development. This is some references, and thank you. Any question?
Have you considered seasonal data also?
No, I'm not considering seasonal data. Just is 2 years data set is just 2 year data set there. I collect from there and that I use. I'm not considering here the seasonal, but let's try it.
Okay, because in your graph, no, that graph is only going up. So I have not seen that any
Yeah,
difference.
solar solar data set is
because SPF is different in all seasons, right?
Yeah, so that's why
You have
it's showing
considered
that
data set from China data set, right?
yeah. It's open source data set.
Okay, so where is the seasonal effect in that graph?
I'm not considering the seasonal effect, but the data set it looks like is a like in solar power is some month is high, some month is low, but in so that's why looking the seasonal. Is all data set is around the world is same, like is coming same graph like the seasonal graph, but I'm not especially I'm not consider here the seasonal effect.
Okay, and what is the significance of using explainable AI in this?
I just because it's all data set is almost similar types like solar radiation, that 3 or 4 types of solar radiation and the atmosphere pressure. So in the model, like which data set, like which feature is which feature is more impact, like I want to identify the which feature is putting the impact on this model for the getting the results. So
yeah, so after getting that feature, any changes you have done in your system?
No, like when you make when you collect the data set any specific area for your installation the solar panel, so like you have only solar radiation, but others in terms of others features don't have, so you can take that one. You already know that okay, solar radiation is putting the more impact on the model, so I have only 2 or 3. That's okay. Solar it should be solar radiation is there, so you can collect all these 3, so you can put and then make the prediction and you take the decision. Like
okay, that's it from my side.
No questions.
So thank you for the presentation.
thank you.
Up next, we have our last presentation for today. The presentation is presented by Marwa Mokni. She is presenting optimizing cloud computing, effective NLP-based corrective approach for research level management. Ma'am, are you there?
Yes, I'm ready. Hello, everyone.
Okay.
I will share my screen.
Yeah, now you can share your screen.
Thank you. Can you see my screen?
Yes, ma'am, it's visible. You can start.
Hello, everyone. I am Marwa Mokni. I'm from Devo Team Research. It's a great pleasure to be here today to present my work aimed at unifying cloud resource labels to optimize their management. During this presentation, I will present our research context, motivation, the related works, our proposed approach, then the validation results and discussion, and finally I will conclude a conclusion and perspectives. In the cloud computing, there is a wide range of resources from computing power to storage. Each of these resources requires effective management, which is essential for maximizing efficiency, but also achieve significant cost savings. Cloud resources are characterized using labels, which follow a key value structure, make it easy to define and organize them. However, the important point here is that these labels are manually assigned by cloud operators. Labels are far more than just names or identifiers. They play an integral role in resource management, allowing us to track and organize resources effectively. As mentioned before, labels are manually entered by cloud operators, which can lead to several issues. For instance, operators may use different writing styles, conventions, or formats when assigning labels. As is shown in the schema, the operator has deployed two resources, A and B. The resource A is labeled using abbreviations, symbols, and numbers. In contrast, the resource B is labeled using a completely different writing style. And even contains some mistakes, especially in the first label. This lack of label uniformity in the cloud computing can quickly lead to confusion, reduce clarity, and ultimately make resource management more complex and error-prone. Then the question that arises here is how to normalize the label definition in a cloud context. Based on the existing reviews, several tools have been proposed by cloud providers to support label management. Tools like iOS Tag Editor, Google Cloud Resource Manager, Azure Resource Manager typically allow users to create, modify, to governance, to reporting their labels manually. However, they lack a mechanism to promote awareness or enforce automatic label unification or correction. In addition, there is the third-party tools such as Cloud Health, Turbot, Cloud Checker, and Finout, which leverage labels to manage aspects like cost, security, and compliance. Yet none of these tools directly address the core issue of label unification. In the scientific literature, several scientific works have addressed the challenge of label prediction in the context of source code and software engineering. Source code like the works of Andrea et al. And for software engineering like the work of Nan et al. Where methods such as information retrieval and clustering have been explored for this purpose. Other related works on metadata management, many approaches have been proposed that highlight the importance of metadata in facilitating semantic adaptation of web services. As a discussion, we can say that from our study, on the existing, we can conclude that the specific problem of label unification in the cloud environment remains largely unexplored, despite its critical importance for effective resource management. This gap in the literature is precisely what motivates our work. Then our main objective here of this paper is to propose a solution that directly addresses this challenge. Then the proposed solution is structured around three main steps. So first, we extract the characteristic of existing cloud resources, including their labels, in order to build a local referential. Then we analyze these labels and attempt to unify them by comparing them with a knowledge base modeled using a global referential. The outcome of this process, The second process, which is analyze process, is a recommended referential that contains resource with corrected labels. Finally, the last step of our approach is to inject these recommended labels back into the cloud architecture to ensure consistency and improved resource management. The step of analyze is our main approach of label unification, which relies on natural language processing techniques, specifically combining semantic and syntactic similarity analysis. By leveraging both types of similarity, our objective is to capture not only the structural resemblance between labels, but also that underlying meaning, leading to more reliable label recommendation. The combined similarity method analyzes local labels both semantically and syntactically by comparing them with global labels in the knowledge base. A final similarity score, which is this combined score, CS, is then computed based on weighted combination of the individual semantic and syntactic scores. For evaluation purpose, we used our custom built experimentator to generate 5 initial datasets. We then applied different label degradation approach to each dataset in order to create additional ones. This degradation approach are in terms of syntactic and semantic degradation with different degrees. In terms of NLP analysis method, we tested several techniques in our work. For semantic analysis, we utilized models like BERT and FR core news similarity, and other methods have been tested. While for synthetic analysis, we employed Jarwinkler and Levenstein methods, which are the widely used methods for synthetic analysis in the existence. For the evaluation of our result, we applied equivalent weights for the combination analysis. And we have used the F1 score used as our primary evaluation metric. Finally, we included the GPT-4 solution model for comparison purpose. For semantic analysis, yes.
Sorry to interrupt, but your 9 minutes are over.
I don't understand your question.
Sorry to interrupt, ma'am, but your 9 minutes are over for the session.
9 minutes. Okay.
Yeah.
I have.
You have to wrap up. Yeah.
Okay. Okay. So in terms of semantics analysis, the results demonstrate that the method of FR core news achieved the highest F1 score. In terms of synthetic analysis, the results show that Jarwinkler and Levenstein methods are remarkably similar results. So we can that both methods are optimal for synthetic analysis. For combined analysis, we have combined the most optimal methods for semantic and synthetic analysis. So results show that BERT similarity and the FR core news model, when combined with the synthetic methods tested, produced almost identical F1 score results. Then the choice of synthetic methods has a significant impact on the analysis. Finally, we have compared our approach with the combined approach of FR core news and Jarwinkler with the solution of LLM GPT-4. Results show that GPT-4 performs slightly better. However, it's important to note that the performance difference remains relatively small, not exceeding 0.05. As a conclusion, in this paper, we have addressed the critical challenge of label unification in a cloud environment, which is largely unexplored in both scientific literature and industrial solutions. We have proposed a combined approach of NLP techniques, and we have demonstrated that semantic and synthetic similarity analysis can effectively unifying cloud labels. Our results are promising, showing satisfactory performance. And thank you for your attention. I'm open for questions.
Okay. You have done comparison analysis with some papers. Okay, but I seen all those papers are from 2010 and 12.
Yes, but we haven't compared our work with other papers because we haven't found works that address this problem of label unification. So in literature, there is no approach that addresses this problem. So the list of related works are just for presenting the works that address that uses the NLP techniques, but not exactly the same approach, the same problem. Then there is no recent work for comparing. That's why we have used an LLM approach for comparing purpose.
Okay. But nowadays many cloud providers are using some tools like Terraform tool is there.
Yes.
AWS is using its AWS Cloud Formation tool. Okay.
Yes.
So already in these tools, this has been taken care of. Label formation and all these things. Just
No.
compare. Yeah.
Yes.
So compare your work with that also, so that you can improve your work.
Yes, okay. But the problem of unification, no tools, no cloud tools propose this. They propose convention and standardization of labels, modifying labels, but not label unification. This issue is not addressed. But
Okay.
yes,
So
we will
please
do
go
our
through.
review.
Yes.
Yeah.
Yes.
Mhm,
Please.
mhm.
Yeah, but this is good idea. Combining, taking NLP input
Yes.
to give labels. Yeah, good.
Thank you.
No question. Yeah, that's it from my side.
Thank you.
Thank you, ma'am. So I declare all the presentations are done. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in 11th version of the 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team ICTIS 2025. Also, the recording of the session will be available on the website within 3 working days. Just a second. I thank our session chair, Dr. Priyanka More, for chairing the session. A token of appreciation to the chair on behalf of team ICTIS 2025 and Global Knowledge Research Foundation and partners. I also thank our second chair for the session, Dr. E. Sujata, for chairing the session. A token of appreciation to chair on the behalf of team ICTIS 2025 and Global Knowledge Research Foundation and partners. Ma'am, do you have any closing remarks?
Hello, am I audible?
Yes, ma'am, you are audible.
Yeah. So thank you all presenters for your nice presentations. You are really doing good research work, and whatever questions we ask, just consider it as positive suggestions, improvements in your research work. Thank you. Thank you all.
Thank you, ma'am.
Yes, I do find some innovative research ideas and well appreciated about your research findings and your presentation and your hard work. Congratulations to all. Thank you so much.
Thank you for your valuable presence, ma'am. I kindly request you all to switch on the cameras for a quick snapshot of the virtual conference.
Hey everyone, thank you for your valuable presence.